Yeah, hello. This is another day. I'm with you, your teacher Richard, and today we're going to talk about some different functions and some different problems. For example, today we are going to look at functions, composite of functions. We're going to look at linear equations, parallel equations, how to find parallel equations and their characteristics. We're also going to represent inequalities in a number line. So, for example, let me introduce about composite of functions. Composite of function, it involves f and g. In that, if f and g are functions, the composite of f with g is a function of f of g. For example, this is x, this is our number. Then g of x, then f of g of x. The function of x to g, that is g, from there it is also mapped to x maps g into g of x, and then g of x is mapped by f into f g of x, for example. And then x can also be mapped by the range of g into this directly. Then, for example, when you see something like that, that means f of g. This sign here means off, but it's a small hole. You should indicate a small hole. So f of g of x into brackets is equals to f of g of x. This one should be in brackets. So, for example, this is a composite of x into g of x, and then from g of x to f of g of x. If, for example, you should understand composite in that way. Then I'm going to give you an example. For example, this is an example, a good one. It says the composition of functions if f of x is equals to x squared and g of x is 2x. Find the composite of f of g and g of x. Remembering that solution, let's do this solution. f of g of x, this should be f of g of x. You should find the composite of f to g of g. Then you are told that the f of x is equal to x squared. So the solution is f of g of x, and then g of x is this 2x. Then you go down there, you say you break down the sum into steps. Let's now break the brackets. Let's do the brackets, and then inside there g of x is 2x. You should remember this 2x is the value of this one. Then you come down here and find the value, write the value 2x, and then remember f is also given. F is this value x inside there. So instead of writing f here, you write this value, and this value is all of this. So you simply say this one squared, because all of this is the x. Okay, so now you come there and find x, 2x squared, that is 4 multiply raised to 2, and then x squared. That becomes f of g of x. That becomes your answer. Let's go to g of f of x. g of f of x, let's do it behind here. That is 1, that is 2. G of f of x. This is you solve it this way. G will be outside because it's a composite of f, and then f will be inside x there. F should be in a small bracket, bigger bracket outside the f. Then you say, because G is outside the bracket, you give an x for f, and f is x squared. That is your f. Then you go down there, because you've already solved the brackets, you've gone down there, you say G is also given, and x is all of this. So your x, if your x is all of this, it is 2 into x2 squared, x squared, because this x you see here is a value which is inside there, the value of f. So to finish your sum is g of f x is equals to 2x squared, and that's your answer. That is the composition of g to f. This is the composition of f to g. Guys, if you don't understand, I will tackle this one later. We'll do another sum. If, for example, some of you will request I will do that. So let's now go to another problem. This is about lines, parallel lines. I will also do the gradient of perpendicular lines, but today we are going to see about gradient of parallel lines. For example, this problem says the line which joins the points A into 3, k and B into -2, 5 into brackets is parallel to the line whose equation is this. So these points make this equation. These points make an equation which is parallel to this equation. So find the value of k. Finding the value of k, you should know the solution. You should know the parallel lines gradient are the same. So if this equation has this kind of gradient, you should know the other one are the same. So let's use this equation to find the value of k. 5y plus 2x is equals to f. You should reduce this equation into the form y is equals to mx plus c, where m here is the gradient. You should know m there is a gradient, and so this equation is not in this form, so you should reduce this equation to be in this form. So it will remain 5y is equals to minus 2x plus 7. Reduce it further, divide by 5, divide by 5, divide by 5. It will be, this will cancel with that. It will remain y is equals to negative 2x over 5 plus 7 over 5. Now this becomes our gradient. This is the gradient of that equation. And you are given that a, so line AB as is gradient 2 over 5x negative, and so the points A and B are this. So take the coefficients, the components of this equation, that is x y of this A and then x y of B. X of this one, we start with y. So y is k minus 5, and then x is 3 minus 2. is equals to negative 2 over 5. Okay, negative 2 over 5. So this equation goes this way: 5 into cross multiply 5 this way and negative 2 this way. 5 into k minus 5 into brackets is equals to negative 2 into minus 3 minus 2 is 5. Okay, so there it goes. 5k minus 25 is equals to negative 10. So 5k minus 25 is equals to 10. I mean, it's equals to negative 10. So 5k is equals to negative 10 plus 25. This 25, when it's a, when it goes to the other side, becomes positive. Alright, is the case of making k the subject. So 5k is equals to negative 10 plus 25. That is negative 10 plus 25. In a number line, you start from negative 10 to 0 to 25. That gives you 15. So k is equals to 5. 15 divided by 5, that is by 5, 1 by 5, 3. So k gives you what? 3. The value of k should be 3. So we are through with that one. Next time we'll do about gradient over parallel. I mean over perpendicular line. So for example, let's look at this one. Let's look at this one. I don't know if this one is clear. The third sum. This is the third sum. Where is it? Is this one? Find the range. Find the range of values of x which satisfies the following inequalities simultaneously. 4x minus 6, it is greater or equal to x minus 12. And then 8 minus 3x is greater than 2x minus 7. You should solve this equation this way. If 4x minus 6 is greater or equal to x minus 12, this is for you to solve this equation, you should group all the like terms together. That is 4x, and then x in this other side is let's look at this one in a different paper, because this paper is a little bit blurred. It's not clear. Let's do it in the next step.